Let's start with a simple fact. Iran has major water problems, and the country has come up with some pretty ambitious ideas to solve them. At one point, Iran tried to strike a deal with Turkmenistan to build a pipeline network and buy some water from its neighbor's main river, the Amu Darya. It didn't work out because every country in the region struggles with water shortages, and several neighboring states are already drawing water from the Amu Darya. On top of that, Afghanistan's currently building a massive canal that'll drain the river even further. There's another neighbor nearby who could sell some water, Pakistan, where the Indus River flows, but for a number of reasons, that plan had to be scrapped too. Maybe it's time to drop the idea of pumping water from somewhere. Nope, Tehran came up with a new idea. Start pulling hundreds of millions of gallons of water from the Persian Gulf and distributing it hundreds of miles across the country. Yeah, it sounds crazy, but it's happening. And now we're going to break down all the details of this life-saving project. This is the Amir Kabir Dam and the reservoir it created with a capacity of 53 billion gallons. It supplies water to Tehran, the capital of Iran, providing water for industry, irrigating 123,000 acres of farmland, and serving as a water source for countless people. And here's a photo from 2024 that must be alarming for anyone living in an arid climate. Water in the reservoir isn't replenishing fast enough. That's already a big issue, but there's something even bigger. The area around the dam, and Tehran isn't even the driest part of Iran. There are way more problematic regions in the country when it comes to rainfall, like the central part, the south, and the southeast. They get an average of 0 to 10 inches of water from the sky every year. Basically nothing to keep any kind of activity going. So how about using groundwater instead? Well, this is exactly what a lot of places in Iran look like right now, where water's being pumped from underground. What you're looking at is a real sinkhole. Some parts of Tehran might even end up underground soon, the city sinking at about 10 inches per year. It's not happening evenly, so there won't be one big hole, but a capital that's partly caved in isn't exactly a pleasant sight either. Why does this even happen? A sinkhole forms because too much is taken away. The water level drops, nothing fills the gap, so a hollow space appears, and then everything caves in. So in its desperate attempt to get water from anywhere, the country's rapidly losing its groundwater. Iran's Ministry of Energy estimates that the country loses 1.3 trillion gallons of groundwater every year due to over-extraction, and over the past 5 decades, Iran has depleted about 70% of all the water stored underground. In 2018 alone, the country pumped out 25 trillion gallons of groundwater. And while that's 51% of its available renewable resources, it still far exceeds the safe withdrawal limit. The whole situation is getting worse due to climate change, which is causing more and more droughts across the country. You can see it clearly on this map. The deeper the color, the bigger the water issues in that region. The vast majority of Iran is just one big water crisis. The most interesting part is that none of this is stopping the population from growing. Back in 1960, the country had just over 21 million people. Now, in 2025, that number has shot up to a whopping 90 million. That's more than 4 times as much. I think we all get what a population increase means when a country's already facing a water crisis. More people need drinking water. More factories and farms pop up to produce goods for the population. That also ramps up resource demand. The World Resources Institute says Iran is the most water-stressed country on the planet. Each year, they withdraw 80 to 100% of their renewable water supply. They use all they have for agriculture, industry, and everyday needs. That means almost nothing is left for dry spells or shifts in rainfall. A pretty grim picture. And naturally, Iran's government's wondering where to get more water. First, it was concluded that dams were needed. By the middle of the last decade, over 640 of them had been built in Iran, with 523 of them considered large-scale structures of this type. Yes, water's building up. The total capacity of all the dam's reservoirs is more than 13 trillion gallons, so with the construction, there's a ton of water available for irrigation, industry, and farming. But in the end, the water in the rivers is decreasing, which leads to the drying of some lakes. For example, check out Lake Urmia. This is a shot from 1984 when the lake surface area reached 2,300 square miles, and this is 2023. Once the 6th largest saltwater lake on Earth, it shrunk to less than 10% of its original size. You could say the lake is already salty, so you can't drink from it. Yeah, but at this rate, it'll just turn into one big salt flat, and that'll only make climate problems worse. In Iran, they realized that they need to find a different solution in this situation. Other sources of water for the population, industry, and agriculture. There aren't many places on the map where you can get drinking water, so they turned their attention to the Persian Gulf. There's a huge amount of water just waiting to be delivered somewhere inland, and nearby is the Gulf of Oman, also a great candidate to serve Iran's needs. The only problem is that both water sources aren't fit for normal use because the salt content is off the charts. For example, the water of the Persian Gulf has an average salinity of around 1.41 to 1.45 ounces per 2.2 pounds of water, and the situation's about the same in the Gulf of Oman. At the same time, the average salt content in the world's oceans doesn't exceed 1.2 ounces per 2.2 pounds of water. Salt water is generally considered a problem, but not in Iran's case. The country just had to look across the shore and see how Saudi Arabia is actively desalting to supply its land with drinking water. Here's the plan. Take water from the Gulfs, desalinate it, and then direct it through artificial water channels to the necessary locations across the country. So the first route starts at the Strait of Hormuz, where the Persian Gulf connects with the Gulf of Oman. The water's collected, desalinated, and then travels through a pipeline across the Hormozgan province to Kerman and Yazd. The total length of the route is 513 miles, and the annual production is 47 billion gallons of desalinated water. Of these, 13 billion gallons are taken by the Hormozgan province. The water is distributed to everyone who needs it. The remaining 34 billion gallons, which go to Kerman and Yazd, are used for industry without any exceptions. The thing is, the provinces have three industrial complexes: Golgohar, Sarcheshma Copper, and Chador Malo. Their importance can't be overstated because the Sarcheshma Copper has several smelting plants and one of the largest mines in the world. For this reason, a lot of water is needed, and continuing to take it from the population and agriculture is risky because if the shortage gets worse, unrest will start. So in this case, reducing the load on existing water sources and using desalinated water from the Gulfs for production is the most fitting solution. At the moment, this part of the huge network is already operational, so everyone's enjoying its benefits to the max, even Iran itself, which spent about $50 million on construction. And still, 47 billion gallons per year isn't quite enough to provide drinking water for the two struggling provinces. The Iranians, of course, thought of this, so alongside the first pipeline, they opened a second one, exactly the same. However, it can transport 53 billion gallons of water per year. There's also a third route that starts in the Gulf of Oman, passes through the provinces we've already mentioned, and then moves into the new province for the system, Isfahan. Today we've already talked about Iran's water problems, but here they're probably the most obvious. Since 33% of the province's area is desert, moreover, 10% of the country's deserts are located right here, so water problems are pretty much a given. And the pipeline with desalinated water running right here is the most reasonable solution. It's also one of the priciest. Investments in this pipeline amount to $2.7 billion. But even here, everything makes sense. Iran had to and will have to lay a pipeline across deserts, mountains reaching up to 4,900 feet, and under rivers, which for sure increases the construction cost. Plus, the solution will definitely pay off, as most of the water will go back into industry. After the construction is finished, a pipeline will appear on the country's territory, which, thanks to its two sections, will be able to transport about 158 billion gallons of desalinated water to a province in desperate need of it. Right now, it may seem like Iran isn't really concerned about the population that's suffering from the water shortage. Industry's much more important. However, another pipeline is meant to challenge this. The east of Iran is the least developed part of the country, including provinces like Sistan and Baluchistan, South Khorasan, and Razavi Khorasan. Sistan and Baluchistan seems to have huge potential for industrial development since it borders Pakistan and Afghanistan, which means something could be produced here and then sold to the neighbors. But things are really bad here. The industry's practically non-existent, and every new business is like a miracle. Agriculture's developed here, but it's also problematic for the same reason that new businesses are rare. The issue is the severe water shortage. There is rainfall here, but it's usually between 2.7 and 5 inches a year. Plus, sometimes the rain comes down in a continuous flow, causing nothing but damage. But maybe there's some way to collect the falling water? Probably not, since in the summer the temperature can hit 122 degrees Fahrenheit, making anything that falls evaporate right away. Do you know what's really popular here and just works so well? Camel breeding, as the animals feel absolutely great in this hot, dry climate, and that's just another sign that there's not much water around. South Khorasan, located north, is also a problematic area. The average annual rainfall here is 5.2 inches, 22.7% of the area is desert, and another 63.3% is desert pastures. However, industry is much better developed here. Still, due to the lack of a key drinking resource, development happens very slowly because many people simply migrate to places with more water. The northernmost of the eastern regions of Razavi Khorasan, there's less desert land here and the climate's pretty good for farming. The province ranks first in the production of cherries, turmeric, melons, saffron, and plums, and also produces many other agricultural products. But lately, there are more and more problems here due to climate change and the active extraction of groundwater. It's just running out. Plus, there's less rainfall, which means that soon the largest agricultural producer in the country, Razavi Khorasan, might turn into a dry area that most of the people will leave. But let's not focus on the negative, because as we've seen, Iran is working on creating artificial rivers to bring water to the areas that need it most. One of the pipelines being built will run through these same eastern provinces. The water's taken from the Persian Gulf and then stretches over 833 miles through the provinces that need it most: Sistan and Baluchistan, South Khorasan, and Razavi Khorasan. The previous pipelines can't even compare to the new one in terms of performance because there was no need to supply such a huge amount of land with water. The water pipeline through 3 provinces has a capacity of 634 billion gallons of water. Because of this, the pipeline will become the largest desalination and water transportation project in Iran, and it'll also require incredible costs reaching $3.2 billion. As of 2023, 12% of the entire route has been completed, and we can't expect all the work to be finished anytime soon. The reason's simple: it's really hard. Designers, engineers, and builders have to deal with all sorts of terrain, which isn't exactly easy. Deserts, mountains, hills, in short, everything that slows down construction and costs a lot. On top of the construction complexity, there's the opinion of many experts who say, maybe we should do something about evaporation instead of laying huge pipelines all over the country. You can't argue with that. Look, in general, about 105 trillion gallons of rain fall in the country each year. Do you know how much of that evaporates? 70%. Only 30% is available for consumption. This mainly happens, of course, because there's no proper infrastructure to catch the Iranian seasonal rainfall, which hits the country all at once at certain times. Imagine one small step, just cutting the annual evaporation by 1%, could meet the water needs of small industries in the country. To avoid water problems, of course, they need to invest in new infrastructure suitable for the country's conditions, but overall, experts say that the most important thing is to develop a policy for managing water resources. For example, many critics of the Desalination and Transportation Project argue that the water consumption in the country's industrial sector is very low, and on the Central Plateau, where the main branches of the project are heading, it's 264 billion gallons. Instead of spending billions of dollars turning salt water into fresh water and then transporting it, they could just redirect some of the current consumption from agriculture to industry. Another thing to consider is that carrying out projects to transfer water from the sea leads to increased fossil fuel use and carbon emissions in the atmosphere, damaging the environment. But the country, which already accounts for about 1.8% of global greenhouse gas emissions, ranking 8th in the world on this front, is unlikely to pay much attention to this, especially since it's one of the few countries that hasn't ratified the Paris Agreement. But the focus is still on desalination. So it's safe to say the construction of both this pipeline and the rest of the massive project to deliver desalinated water will definitely be completed. You know what else is helping Iran in its fight against the endless water crisis? The unexpected fact, 15% of the country's total water needs are met through something that was invented about 2,500 years ago. It's the Quanit, a water supply system first developed in ancient Iran. It's used to bring drinkable water to the surface from an underground aquifer or well. Of course, in ancient times, there was no modern equipment to locate underground water and no devices for pumping the water out. That's why ancient people came up with a brilliant system. There are water clusters at the foot of the mountains. The water naturally runs downhill, so no extra tools are needed to make it move. So people came up with a way for the water from the higher ground to just flow down to the place where it would be used. And that's how Quanits were created. The system consists of a series of vertical shafts similar to wells connected by a gently sloping tunnel. The water flows down it without any extra push, and everyone is happy. In fact, there might be doubts about the effectiveness of the system in tough Iranian conditions. These systems are old, slow, and building something like this isn't as easy as just laying a pipe and installing a pump, but Quanit's truly saved the day. The thing is, the ancient water tunnel is completely underground, so the water's resistant to evaporation in any climate, even the harsh Iranian one. That's why the system was invented here. As for pollution, it's generally harder to contaminate the underground water because you need to gain access to it. The system's also resistant to floods and earthquakes, as well as other disasters common to the modern world, technological accidents, and military destruction. And this is a yakchal, in simple terms, a refrigerator. In more exact terms, it's a sophisticated ancient system that Iranians might still use to store ice in the desert in summer. So what does this have to do with the ancient water transportation system? Ice is placed in a space surrounded by thick walls that do a great job of keeping the cold in. At the bottom, there's a connection to a quanit from which cold air flows. It blows over the ice inside the yakchal and pushes warm air out through the ventilation system. That's it. The frozen water stays frozen and doesn't melt, even in desert conditions with high temperatures. In short, you can still use ancient methods to deal with water shortages. However, without modern solutions like desalination, it won't be enough. Only a combined approach can solve the water crisis.